In this video, I'm going to talk about scientific notation, but I want to do a quick review on exponents first. So we have this series, 10 raised to some power. So I want to talk about what does this really mean. So 10 to the fourth first. So 10 to the fourth, what that is telling us is we're going to take the number 10, multiply it by another 10, and another 10, and another 10. So the base, 10, that's telling you what number to multiply, and the exponent 4 is telling you how many times to multiply it. So we get 10,000. 10 to the third, 10 times 10 times 10, so 1,000. 10 squared, 10 times 10, 100. 10 to the first is just 10. Now this one, 10 to the 0, we can't take 10 0 times, so you might think that 10 to the 0 is 0, but actually we define anything to the 0 power as being equal to 1. So let's look at the pattern that's emerging here. So when we go from 10,000 to 1,000, we're dividing by 10. 1,000 to 100, we're dividing by 10. 100 to 10, dividing by 10. 10 to 1, dividing by 10. So that's the pattern on the right. We're dividing by 10. Now, if we did not have 10 over here as our base, then we would not be dividing by 10. Let's just say this is 3. Then over here we'd be dividing by 3. So it's not always dividing by 10, it's dividing by your base on this side. Alright, so our pattern on the left is, if we look at the exponents, 4 to 3, subtract 1. 3 to 2, subtract 1. 2 to 1, subtract 1, subtract 1. So let's continue this pattern on. So on the left side, our next one would be 10 to the negative 1. So we can't really take 10 negative 1 times, so we need to follow the pattern to figure out what does 10 to the negative 1 actually equal. So we're going to divide by 10. So we get 1 over 10, or 0.1. So in general, when you have a negative exponent, let's just write this in general. So let's say 10 to the negative x. What that equals is 1 over 10 to the positive x. So that's just in general what these negative exponents are telling you. Now really quickly, before we continue on with scientific notation, I want to talk about measurements. When you're dealing with measurements, you always need to have a number, and most people get that, but the other part that is just as important is you need a unit. So let's just go through a couple examples. So if I was to ask you how much gas does your tank hold, if you just gave me a number, so let's say 12, that's meaningless. I don't know, do you mean 12 gallons? Do you mean 12 liters? What exactly do you mean? So there's your number, but you need to give me a unit as well, so 12 gallons. How much does your dog weigh? Well, you can't just say 100, you have to say 100 what's, 100 pounds. And then how tall is that tree? Again, can't just say a number, can't just say 30, we have to give some sort of unit, 30 feet. It's really important in chemistry, this unit here. You really need to keep track of your units, otherwise problems can get more confusing than they actually are. In science, we're often dealing with numbers that are really large or really small. So let's just do a couple examples. So if we were talking about the distance between the Earth and the Moon, that is about 360 million meters. So that's a pretty large number. So let's think of the opposite end of the spectrum. Typical diameter of a virus is about 0.000000001 meter, so a very small number. Now, we probably wouldn't use the unit of meters for either one of these measurements, but that's something we'll talk about in a later video. So you can see that these numbers both have a lot of zeros. So you can imagine if you were using one of these numbers in a calculation, it could be really easy to leave off a 0, and then that would throw off your entire calculation. So this is where scientific notation really comes in handy. There are two components to writing a number in scientific notation. The first one is we need a number between 1 and 10. Now I say 10, but actually it has to be ever so slightly less than 10. So 9.99999 is your max. It cannot be quite 10. All right, and then the second component is we need an appropriate power of 10. So let's take an example number to figure out what this really means. So let's take the distance from the Earth to the Moon. Okay, so another way to write this is 3.6 times 100 million. So if you'll notice, we actually have our first component here, 3.6. That is a number between 1 and 10. So the second component is we need to figure out an appropriate power of 10. So what I mean by that is 10 to the something. So if you multiply 10 times 10 times 10 times 10, what you would figure out is in order to get 100 million, you need to do 10 to the 8th. So there's our second component. So scientific notation, this number would be 3.6 times 10 to the 8th. Now another way to get this 8 is to count how many times you need to move a decimal point. So what you should do is look in your number and find a decimal point. Now this number doesn't have one, so we're just going to pretend it's right here. So we want to move this decimal place in order to get a number between 1 and 10. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. We moved that decimal place 8 spots, got a number 3.6, and then what does that 8 tell us? Well, it tells us the exponent. So it's just a quicker way to figure out your number in scientific notation. So if you'll notice, when we were going into scientific notation, we had to move our decimal to the left. If that's the case, then that means our exponent is positive. So if you're going into scientific notation and you go to the left, your exponent will be positive. So you can remember that abbreviation, LIP. Left is positive. Now this is only when you're going into scientific notation. If you were in scientific notation already and you want to get out of scientific notation, if it's a positive, you would have to go right. Okay, so let's take a really small number as an example. So the diameter of our virus. Okay, so let's try it the second way. Find the decimal. So it's right here. See how many places we need to go in order to get a number between 1 and 10. So in this case, we actually need to move right. So we're going to go 1, 2, 3, 4, 5, 6, 7. All right, so we moved 7 in order to get the number 1. So it's 1 times 10. Now it's not 10 to the 7th. We moved right to get into scientific notation, so it's 10 to the negative 7th. Here we have 5 example problems putting numbers into scientific notation. So you should go ahead and pause the video and try to do these problems on your own. And then when you're done, come back and press play and see if you got them all correct. All right, our first one, 59,000. So we're going to look for the decimal place. We don't have a decimal place, so we just say it is right there. So how many places do we need to move that decimal in order to get a number between 1 and 10? So we need to move it 1, 2, 3, 4. So our number would be 5.9 times 10 to the 4. And we did move it left going into scientific notation, so it would be positive. All right, our second one, we do have a decimal right here. So we need to move this decimal 1, 2, 3, 4 again. So we get 1.3 times 10. But now the difference is we moved our decimal to the right. So it's not times 10 to the positive 4, it's times 10 to the negative 4. Okay, example 3, again, no decimal place, so we'll just assume it's right there. So 1, 2, 3, and we move to the left. So 2.941 times 10 to the third. D, we have a decimal, 1, 2, 3 to the right. So 1.96 times 10 to the negative 3. Okay, and then our last one. 1, 2, 3, 4, 5, 6, 7, 8. So our number is 6.2 times 10 to the negative 8. So you'll notice whenever we have a negative exponent, that's telling us a number less than 1. Positive exponent is a number greater than 1. 3 more practice problems. So in this case, we already have the numbers in scientific notation, and what we're going to do is just manipulate them in order to solve an equation. So go ahead and pause the video and try these on your own, and then when you're done, press play and see if you got the correct answers. So with these, you could just plug these into your calculator fairly easily and calculate the answers. But I want to show you really exactly what you're doing here. So let's take A, for example. Now, A, this exponent here, we're in scientific notation. So that exponent right there, it's positive. Now, we have that abbreviation LIP, left is positive. That's where we would move the decimal. But we're not going to move the decimal left because we're already in scientific notation. When you're already in scientific notation, you have to do the reverse to undo it. So, since the exponent is positive and we're already in scientific notation, we're actually going to move the decimal right to get it out of scientific notation. And we're going to move it right twice. So 1, 2. And notice this blank piece right here, we're just going to fill that in with a 0. So this 5.9 times 10 to the 2, that's telling us 590. And then this 3.2 times 10 to the 3, we're going to do the same thing. Move the decimal 1, 2, 3. Fill these spaces in with zeros. So we get 3,200. So really what you're doing is 3,200 plus 590. So your answer would be 3,790. But if we wanted this in scientific notation, we would find our decimal. If we don't have one, it's there. So we go 1, 2, 3. So 3.79 times 10. And now we're going into scientific notation, so left is positive, 10 to the third. Okay, B. So notice in B, everything is multiplied together. So we could combine this and we could combine this. So we could do 1.5 times 2.5 in one set of parentheses, and then 10 to the 1 times 10 to the 4 in a second set. So let's simplify. So 1.5 times 2.5 is 3.75. And then 10 to the 1, we know that's just 10. 10 to the 4, that's 10 times 10 times 10 times 10. So 1, 2, 3, 4. So in order to get our answer, we would write 3.75 times 10 to the, and then count how many times to be multiplied 10. 1, 2, 3, 4, 5 times. So 3.75 times 10 to the 5. All right, C, last one. So we're going to do the same thing. We're going to combine our 6.5 and our 4.5. And we're going to combine our 10 to the third and our 10 squared. So 6.5 times 4.5 is 29.25. And 10 to the third times 10 squared is, now let's notice something here. See how 10 to the first times 10 to the fourth equals 10 to the fifth? So notice what we did. We added together these exponents in order to get this exponent here. So as long as you have the same base, you can just add the exponents together. So 10 cubed times 10 squared is 10 to the fifth. Okay, so you might think, all right, 29.25 times 10 to the 5th, there's our answer. But we have a problem because this 29.25, it's not between 1 and 10. So we need to just sort of ignore this piece for just a second. Let's convert this piece into scientific notation. So we need to move the decimal place 1 to the left, and we're going into scientific notation, so that means our exponent is going to be positive. Okay, so we get 2.925 times 10 to the 1. Now let's add in this 10 to the 5 piece. And I just said when you're multiplying numbers with the same base, you just add their exponents together. So our answer for this one would be 2.925 times 10 to the 6th.